Hi everyone, welcome to the Empirical Formula Lab. First thing we're going to do, of course, is put on our safety goggles, and we're going to get out the things that we need from our kit, including the two largest beakers, the 500 ml and the 250 ml beaker, the Empirical Formula kit, and our digital scale. So this experiment actually takes a couple of days to complete. But the initial step, really the steps of it only take a few minutes, but it just takes a long time to run to completion and to fully dry. So in this reaction, we're going to start with the 250 ml beaker and our digital scale. The instructions say to open up your empirical lab kit, pull out the materials here, and inside the filter paper you're going to find a couple of rubber bands, a wooden stir stick, and a little saran wrapped piece of steel wool. And the steel wool is made of iron. It's just mostly iron, and it's very finely shredded iron, so it has a lot of surface area, and that's why it's great to use in this experiment, because the high surface area makes the reaction happen faster. So there's actually two pieces of filter paper here. I like to pack extras just in case there's accidents, but you only need one, so make sure to separate those. All right, so the instructions say to measure out about a half a gram of the steel wool. So I'm going to do that, I guess I'm going to use the weigh pan for this. So I'm going to put the weigh pan on here. I'm going to tare it. And I don't need to use scissors. I'm just going to peel away. It's sort of layered. And I'm just going to peel off, tear a piece of this iron wool. And I probably don't even need the pan. I could probably just do it straight on here. Okay, that's not enough. That's only about 0.3, so I'll add a little bit more to this. Little wad here. And now I have about 0.6. Well, that's fine. That works. So I'm going to record the exact mass that I see on my scale. All right, and then I'm going to add this to this beaker, but first what else I need to add to this beaker is hydrogen peroxide. In this reaction, the hydrogen peroxide is our excess reagent. The iron is going to be our limiting reagent. So the amount of hydrogen peroxide we use is not important as long as we're using an excess amount. So I'm just going to pour, I think it said, like 100 milliliters in here, so that's plenty to make this reaction go. And then I'm going to add my steel wool. Now, the steel wool right now, it's in kind of a knot, but in order to make this reaction happen a little faster, I'd love to increase the surface area. So I'm just gonna like tease it apart a little bit and shred some of those layers and just kind of there. So there's a little bit more surface area. Now it's sitting on top of the hydrogen peroxide right now, which is not so good. I want it to be emerged. So I'm going to tuck it down underneath the surface of the hydrogen peroxide. Now if you look at it now, you might see a couple of little bubbles coming off of the steel wool. The reaction is happening. It's just happening super slowly. And if we let it continue happening at this speed, and this is actually an oxidation reaction that's happening here, the iron is getting oxidized, it's turning into rust. And as we know from everyday items that we own, like bikes or something rusting out when they're exposed to water, all right, that definitely happens, and we feel like it happens quickly, but it really takes several months. All right, we don't want to wait several months for this piece of steel wool to get nice and rusty, so we are going to expedite this reaction. We're going to catalyze it, speed it up, by adding a little bit of salt, of table salt. This, ladies and gentlemen, he's, she's, and theys, this is why your cars rust so fast in the North Country and in wintry areas that where the roads get salted. Okay, salt is a catalyst for iron oxidation. So I'm just, whatever, just a little pinch of salt in there. I'm going to stir it around, get it dissolved in the hydrogen peroxide. All right, and when I do that, I'm going to start seeing some action. This is very coarse salt kosher salt so it's not dissolving very quickly. Okay, now I see something happening here. The solution all of a sudden got kind of milky. All right, and I'm watching it, and if I look down into it, I don't know if you can see this, it's sort of turning tan, and you can almost see bubbles coming off, small bubbles coming off of the steel wool. All right, so don't forget to add the salt or nothing is going to happen. Nothing interesting is going to happen. But once you add the salt, you see it starts happening right away. And I don't know if you can pull out the steel wool a little bit. It'll start to look orange. But basically what's happening is it's rusting, and that rust is sort of precipitating slash being suspended in the solution. So that's why it's looking kind of orangey tan. By the end, it's going to be like a very rust orange brown color. So this reaction is going to take a couple of days to go to completion. Hopefully you can see it bubbling actively, and you're going to let this go for a couple of days. You might want to come and stir it here and there, but by 24 to 48 hours this will be completely dissolved. The iron will be completely oxidized into rust. And then you're going to come back and you'll have just like this dark orange cloudy solution. And then you're going to filter it. So previously we used Whatman filter paper, which is proper chemistry filter paper. Today we're just going to use a good old coffee filter. So you're going to set up your filtration system in this large beaker, the 500 ml beaker. So you're just going to put the coffee filter in it and sort of fold it over, and then use a rubber band to hold it in place. Oops, just sent that rubber band flying. Try another one. These ones might be a bit of a tight fit. And so we just rubber band that on like so. And then we'll be able to pour this solution in here. Now, just like with the last experiment where we had a filtration step, it takes a while. You want to sort of half fill the filter and then let it drip through. The drip through filtrate should be clear, and all the orange rust should be contained in our filter here. So once you have poured it all through and it has dripped dry pretty well, you're going to want to put it somewhere where it can dry for a couple of days. Someplace warmer is better. And then once it's pretty dry, you will be able to remove the filter full of rust, essentially powdered rust, and you can sort of twist it closed. You can see this is still going. It's getting real nice and orange. It's all bubbly. I'm not very good at showing the camera stuff, guys. I do not have a future career as a YouTuber. Alrighty, so then you're going to take that filter that's got all this orange nastiness in it, and I kind of make it into like a little candy. I twist the top closed, and then it's in like a nice shape for you to actually take the mass of it. Again, like I did in the previous video, I forgot to take the mass of my filter paper before I put it on there. So do make sure you remember that. I guess that's also what the second piece of filter paper can be used for in a pinch, if you forget to take that measurement. Because we will need to subtract the mass of the filter paper from the mass of the entire candy package of rust here. So yeah, coming back, giving this little reaction a little stir every now and then. What else do I want to say? So this dries a little bit more slowly, I think, than the other filter paper, so it may take a couple of days. So give yourself a good, I don't know, 3 or 4 days to do this experiment. Do step 1, day 1, mix these together. And then day 2, you can do the filtration, but then give it a good 48 hours to dry. I actually have you guys weighing this at different time points to assess when it is completely dry. And it is completely dry when the mass is no longer changing. All right, that's how you know there's no more water left. There's no more water evaporating off, essentially. And then you'll be able to use those calculations to figure out the empirical formula of rust. The end.